Hello, this is Severe from Moxa Australia team, and in this video, I will demonstrate how to enhance cybersecurity using an industrial-grade firewall. With latest developments in communication technologies and digitalization trends, cybersecurity becomes more and more important. Some countries have already introduced mandatory cybersecurity management for critical infrastructure, and therefore, there are cybersecurity requirements in most of the new projects. Firewalls are the key devices in fulfilling those requirements, as they provide network segmentation and limit access as described in standards like IEC 62443, NIST SP 800-53, NERC CIP, and others.
This is an example of industrial-grade firewall from Moxa. Model name is EDR-G9010. Not only it has a rugged design with compliance to IEC 61850-3, but also provides several industry-specific software features, such as deep packet inspection and built-in intrusion protection system. Such a firewall could be used to secure wide area network connectivity from substation or remote site to control center, or to segment network of a large industrial site. For this demonstration, I will use a part of our Moxa U topology, which has this firewall as a gateway between this field RTU device and SCADA. The demo topology is quite simple. SCADA uses DNP3 protocol to pull information from field device, and that traffic goes through the router with firewall functionality. I tried to mimic a typical remote monitoring scenario, so let's go over our IP addressing arrangements. The local area network of this site is 192.168.127.0/24, and RTU has an IP address of .144. The entire site is connected to a wide area network that uses 10.0.0.0/24 subnet. One of the common ways to establish connectivity between LAN and WAN is to use network address translation, or NAT for short. This is also how most of the home routers work. To achieve LAN to WAN access, routers should have IP interfaces on both sides and N-to-1 NAT rule. All LAN devices will be seen as 10.0.0.1 on the WAN side. To achieve WAN to LAN access, we need another NAT rule, which is called PAT, short for port address translation, also known as port forwarding. PAT exposes a particular TCP or UDP port of a LAN device to the WAN side. For our scenario, I will expose TCP port 20,000, which is used by DNP3 protocol. On top of that connectivity, we want to have security policies to block anything unexpected. So we will configure firewall rules with deep packet inspection of DNP3 protocol as well. Now that we have a plan, let's do the configuration. Let's log into the EDR-G9010. It already has a LAN side IP address configured as 192.168.127.252. So let's configure WAN side. EDR-G9010 has a VLAN-based interface configuration. So first, I need to navigate to Network Configuration, Layer 2 Switching, VLAN, to create a new VLAN for WAN interface. I will use VLAN 2 and assign it to port 8, which is going to be my WAN port. Now I can proceed to Network Interfaces menu and configure WAN interface. Here, I can select VLAN 2 that was created, set connection type to static IP, and configure the address according to our topology. If we used this for internet access, then a proper gateway and DNS server settings would be required. I'll just key them in as an example. Back to the device summary, now we see that WAN interface is active. With WAN interface ready, I can set up network address translation via NAT menu. The first rule is for LAN devices to access external networks. I'll name it WAN access and set the mode N-to-1. This rule will be applied to all LAN IP addresses, starting with 127.1 all the way to 127.254. And the outgoing interface must be WAN. Second rule is to expose RTU for DNP3 communication. Mode is PAT, DNP3 is using TCP, so I'll select TCP as a protocol. The request will come from SCADA, so incoming interface should be a WAN, and I'll use a standard DNP3 port 20,000. The translated packet should be sent to the RTU, so I'll key in 192.168.127.144 as IP address and the same TCP port 20,000. These two rules enable LAN devices to access external WAN networks and allow external SCADA hosts to communicate to RTU with DNP3 protocol. Let's quickly verify connectivity. In the SCADA, I have created a DNP3 channel pointing to WAN IP address of the EDR, since we have the port address translation rule. I have also created a very simple human-machine interface that shows the status of one binary input and one binary output channel. When status is shown in black text, it means that the connectivity is good. Let's also confirm that by changing the state of binary output to close. As you can see, it is successful. While we were performing the SCADA test, I had Wireshark running and capturing packets. I've got a filter to show DNP3 traffic only, so we can review communication between the SCADA, which is 10.0.0.100, and RTU behind the router, which is represented by 10.0.0.1. There are several function codes used during the initial connection. We need to know them in order to set up a proper policy later. These messages are then followed by periodic polling with read function code, and when I triggered the binary output to change state, a direct operate function code was used followed by a response. So we've got our communication working well. Now let's apply some firewall rules to protect it. I'll start with layer 3 to 7 policy, which is a basic stateful firewall. It must be globally enabled, and I'll keep the default action as deny to create a whitelisting policy. I can start adding rules by clicking this plus icon, and for this scenario, one rule for allowing DNP3 would be sufficient. I'll give it a name, a description, select incoming interface as WAN, and outgoing interface as LAN to match the direction of TCP session. And of course, the desired action is to allow this traffic. Furthermore, we want to narrow down this communication to 2 hosts only. The source will be SCADA with IP equal to 10.0.0.100. The source TCP port is randomly selected, so we keep it as any. And the destination is going to be RTU with 192.168.127.144 as IP address. Moxa routers have predefined settings for commonly used TCP ports, so we can simply select DNP3 from the list. To sum up, this rule allows SCADA to initiate DNP3 session with RTU, and everything else is prohibited by the default deny all rule. The real advantage of an industrial-grade firewall comes with deep packet inspection capability. In EDR-G9010, we have an additional network security package that can be obtained from Moxa.com and installed in this menu. Once it is installed, you will see Advanced Protection under Firewall menu. As you can see on this dashboard, I have a package installed with few protocol engines including Modbus, DNP3, MMS, and IC104. To enable this so-called enforcement, I'll navigate to Configuration menu when I can enable it globally and disable unnecessary protocol engines. Please note that the default action is to reset the communication session. So again, we will use a preferred whitelisting approach. The next step is to create protocol filter objects, which are essentially describing the details of protocol communication. The parameters we need to define vary depending on the protocol used. So for DNP3 objects, we can define DNP3 addresses, which are configured as 4 for SCADA DNP3 master and as 0 for RTU DNP3 outstation. Also, we can define function code, group, and variation. For this demo, I'm going to use only addresses and function codes to define protocol filtering. This is quite a meticulous process that requires understanding of the DNP3 communication. So here, I will create a protocol filter object for every function that we previously saw in Wireshark, except the direct operate function, which was used for triggering the binary output. So I've got 8 objects in total for this scenario. Now, with objects defining DNP3 parameters ready, I can proceed to creating protocol filter policies. Each policy has a name, a from and to interfaces, which depend on the direction of the communication. It's important to highlight that for DNP3 protocol filtering, we need to create rules in both directions for both request and response. We also need to define IP addresses of source and destination devices, select a proper underlying protocol, which is TCP in our case, also define command type, and finally select one of the protocol filter objects that we created on the previous step. In a similar way, I need to go through all DNP3 interactions that we want to allow and create policy for each request and response that are expected. And since we have a default action of reset, the policies are going to accept the traffic and thus become a whitelist of communication patterns we want to see in our network. This is a time-consuming process, but it provides a better cybersecurity posture compared to the opposite approach when we allow everything by default and deny only selected functions. So, I've created 8 policy rules in total that define DNP3 communication, where SCADA can connect to RTU and read the input and output channel information. Now that we've got our cybersecurity tightened, let's test it and confirm that it works as expected. The SCADA still runs without issues, which is a good sign. I can confirm that by checking the status of the Mimic item. It is online, which is expected as our policy allows DNP3 communication packets related to remote monitoring. However, as soon as I try to control the binary output, we see errors saying that the control request has failed and communication to RTU is down. This means that protocol filter of EDR-G9010 detected a policy violation and dropped the TCP session between SCADA and RTU. I'll acknowledge these events, and after a while, SCADA initiates DNP3 connection to RTU again. I had a Wireshark running in the background for this test as well, so let's see what happened on a packet level. Here is our direct operate command coming from SCADA to RTU, which had no response, and there is about 30 seconds of silence in DNP3 communication after it. If I remove the DNP3 filter to see all the packets, I will see that right after the direct operate command, EDR-G9010 sent a TCP reset flag to terminate the session. This is how the protection works. On the EDI itself, I can go to Advanced Protection Dashboard and see that there was a DNP3 enforcement hit. And once I click on it, I can see the log which shows what happened, which devices triggered the enforcement, and that the action was to reset the communication. The policy ID shows the rule number, so it was the last default rule, which is set on configuration page here. Just to recap, we successfully established a connection from SCADA to RTU using a router and features like WAN interface, NAT N-to-1, and port address translation. And after that, we improved cybersecurity using firewall rules with DNP3 packet filter that allows only the traffic that we expect and drops everything else. Of course, each project requires a different set of firewall rules, but I hope you got the idea from this demonstration. Good news is that this functionality is available on cellular gateways as well, like this one called OnCell G4302, so it can be a good option for sites that are connected wirelessly.
Not only OT firewalls look industrial, but they also think industrial. Especially when automation systems rely on unencrypted communication, having an ability to inspect the traffic and define granular security policies is essential for proper network segmentation. These industrial secure routers have many more features to protect from malicious traffic, establish VPN, and solve various IP connectivity tasks. Reach out to your local Moxa representative to learn more. Thank you for watching, and see you next time.